Have you ever wondered what happens when you press the clutch pedal in your car? How does it smoothly allow the drivers to shift gears without stalling the vehicle?
Have you ever thought why different vehicles use different types of clutches?
Come, let's dive right in.
Hello everyone. Today's topic is about clutches. Clutches are the mechanical devices used to engage and disengage power transmission between engine and the drivetrain. They come in various types based on design, operations and application. Here are the main types. Based on the friction surface arrangement, there are three types of clutches: single plate clutch, multi-plate clutch and cone clutch. Single plate clutch is common in most manual transmission cars, consists of one friction plate. Multi-plate clutch are used in high performance cars and motorcycles. Multiple friction plates increase torque capacity. Cone clutch uses conical friction surface found in racing cars and heavy machineries. So based on the operating mechanism, clutches are divided into three types: manual clutch, hydraulic clutch and electric clutch. Manual clutches engages or disengages using clutch pedals, whereas hydraulic clutches uses hydraulic fluid for smooth operations. Electric clutch uses an electromagnetic field to engage and disengage.
So based on actuation, clutches can be classified into three types: centrifugal clutch, semi-centrifugal clutch and electromagnetic clutch. So centrifugal clutch engages automatically based on engine speed, that is your input. So it is used in scooters and go-karts. So semi-centrifugal clutches, they are used in both centrifugal force and manual control. So this is used in high-speed vehicles. Next one is electromagnetic clutch. So this is engaged by an electric field used in automation and hybrid vehicles. Next one is based on medium of operation. This is of two types: dry clutch and wet clutch. Dry clutch, this operates without lubrication, which offers better efficiency but weighs faster. So this is used in sports cars and motorcycles. Next one is wet clutch. Wet clutch operates in oil for cooling and durability, and this is found in motorcycles and automatic transmissions. Next, based on special applications, they are classified into three types, that is dog clutch, positive clutch and overrunning clutch. So dog clutches, this uses an interlocking mechanism instead of friction. So this is used in like racing transmission. Positive clutch, they use mechanical locking instead of friction. Next, overrunning clutch, so they allow rotation in one direction only. So this is used in starter motors.
A clutch is a mechanical device that connects and disconnects the engine from the transmission system in a vehicle. Its main function is to engage and disengage power transmission whenever it is needed. The clutch works on the basic principle of friction. It has two main parts, that is your flywheel, which is connected to the engine and is always rotating. You have your clutch disc or your friction disc that sits between the flywheel and your pressure plate. So what happens is, when the clutch is engaged, the clutch disc is pressed against the flywheel using a pressure plate and springs, allowing power to transfer from the engine to the transmission. When the clutch is disengaged, that is when you press the pedal, the clutch disc is separated from the flywheel, stopping power transfer. I will now explain the step-by-step process of how a clutch works. The first main process is pressing the clutch pedal, that is when your clutch is in disengagement. The driver presses the clutch pedal. This action pulls the release bearing, which moves the pressure plate away from the clutch disc. The clutch disc separates from the flywheel, stopping power transmission. The engine keeps running, but no power goes to the transmission, allowing gear changes. Now the second process is shifting of gears. Since power is now disconnected, the driver can now safely shift the gears. The gearbox selects a new gear ratio suitable for the speed in load. Now the third is releasing the clutch pedal, that is the engagement part. The driver slowly releases the clutch pedal. The pressure plate now pushes the clutch disc against the flywheel. Friction between the flywheel and the clutch disc allows smooth power transmission. The vehicle now moves forward smoothly in a selected gear.
Now let us see the parts of diaphragm clutch. Diaphragm spring, pressure plate, clutch plate with a friction lining, and the springs for the damping. And this is a flywheel. This is a multi-plate clutch. As the name suggests, we have multiple pressure plates in it. So now let's know about the centrifugal clutch. This is the outer cover of the centrifugal clutch, and if this outer cover rotates, as you can see, the rear wheel starts rotating along. but this inner part doesn't rotate. If you can see, if this rotates, inner part doesn't rotate. So this is indirectly connected to the engine. So when the engine rotates, the inner part rotates, but the outer cover doesn't. If the outer cover rotates, this doesn't. So to engage with that, let us see what's inside that. This is the cover, and you have a lining where this will be in friction with this. So this is called set of 3. When this shrinks and also expands according to the engine speed. If the engine speed is more, this expands so that the surface will be in contact with this surface, and this will start giving a friction moment, friction force. Due to this friction, the cap will also start rotating along. As this rotates, the rear wheel also starts rotating. When the speed is low, this will start shrinking. This shrinks, there will be a gap between the cover and the set of 3. So due to which this set of 3 starts rotating and the cover doesn't rotate. Due to which the rear wheel also doesn't rotate.
Understanding clutch wear and tear is crucial for maintaining vehicle's health. Here's a breakdown of the possibilities, prevention methods and emerging trends. Common causes of clutch wear and tear. First, aggressive driving. Rapid acceleration, frequent forceful gear changes. Second, stop and go traffic. Constant clutch engagement and disengagement in congested areas. Third, towing heavy loads. This increases stress on clutch components and system. Fourth, improper clutch use. Failure of fully engaging and disengaging the clutch. Using the clutch to hold the car on a hill. Fifth, overheating. Excessive friction generates a lot of heat, damaging clutch components. Sixth, lack of maintenance. Neglecting clutch adjustments and fluid check. Now let's look at the prevention methods. First, adapt to smooth driving habits. Avoid rapid acceleration and unnecessary gear changes. Fully engage and disengage the clutch pedal. Second, proper clutch use. Minimize riding the clutch. Use the brake to hold the car on hills. Third, regular maintenance. Check and adjust clutch pedal frequently. Inspect clutch components for wear. Ensure proper fluid levels where applicable. Fourth, avoid overloading. Limit towing of heavy loads, which can prevent a lot of damage that does to the clutch. Let's take a look into future trends and new technology. Advanced clutch materials. Manufacturers are developing more durable and heat-resistant clutch materials. This will extend clutch lifespan and improve performance. Second, electronic clutch system. Electronic clutch system offers smoother engagement and reduces the wear. These systems can adapt to various driving conditions and optimize clutch operation. Third, dual clutch transmissions. DCTs use 2 separate clutches for even and odd gears, providing faster and smoother shifts. While complex, they offer improved efficiency and performance. Fourth, electric vehicle influence. The rise of EVs, which don't adopt or require traditional clutches, is driving innovation in transmission technology. Upon concluding, in essence, future clutch technology aims to enhance durability and efficiency and driver comfort through advanced materials and electronic control systems.